this is pretty intense. This is a lot of people. Awesome. Thank you guys all so much for being here. Thank you for the invitation to come tell you my story. I've been working on getting communities engaged in oceanography and science of the local environment for about the last 10 years now. And I want to tell you a little bit about how I came to do that. So I'm going to break this up into 3 different chapters here, and I'm going to start with the closest community that I was ever a part of, my family and my upbringing. I grew up on the East Coast, and I was lucky enough to spend a lot of time on the water from a really early age. I spent a lot of time in my grandfather's fishing boat, spent a lot of time in pools. I was boogie boarding and out on skimboards all the time. Never really learned how to surf there, but just loved being on the water. Never thought of it as an actual career path, though, until much, much later. And I was taking this chemical engineering course about halfway through my undergraduate career, and we went on a field trip to this place. This is Bayway Refinery in northern New Jersey, and the teacher for that course took us up into the classroom, into the corner office of one of the managers at the facility and said, you could work for your career and advance, and this could be the view from your corner office. And I don't know what the guy was thinking, but that was the moment when I thought, there is no way I'm going to be a traditional chemical engineer. I still love chemistry and math. I still love putting them together. I still love building things. But this is just not the path that I had in mind for myself. Around the same time, I took my first course in environmental science. So who has seen this graph before? Quick show of hands. Awesome. Love it. So this is called the Keeling Curve, for those of you who haven't seen it. This is one of the most iconic graphs that has come out of San Diego, which is kind of a funny thing to be saying. But the scientist down here in the lower right-hand corner, Charles David Keeling, spent most of his career where I am now at Scripps Institution of Oceanography. And back 60 years ago, in 1958, he received funding to start a long-term monitoring program for carbon dioxide in the atmosphere. He thought that he might be able to detect slight changes due to anthropogenic fossil fuel burning, our cars, our industry, that sort of thing. And quite fortunately, we've been able to maintain this program over the past now 60 full years. We just hit the 60th anniversary. And he's seen exactly that. Now his son, Ralph Keeling, maintains the program at Scripps. And over the last 60 years, you can see we've taken carbon dioxide concentration in the atmosphere from the low 300s to now crossing over 400 parts per million. But when you look at this in a historical context, same graph on the right here, but now looking at little air bubbles trapped in glacial ice that people have been able to extract back to 800,000 years ago. If you look at this really long record of carbon dioxide in the atmosphere, you can see that it never went above 300 parts per million for 800,000 years, almost a million years. And now our impact is bringing it from 300 to 400 just in the course of 60 years. Of course, this is kind of a silly way to look at these 2 figures side by side because we're looking at radically different timescales. So if you add the 2 figures, this is our impact here. This is humanity's impact just in the last couple hundred years from fossil fuel burning and agriculture and all that. And I can feel Mike and Nate starting to panic because they asked me not to put too much science and too many graphs into this talk. But I promise there aren't too many more. So I just wanted to show this as some of the motivation for what helped me get into this. I know it's extra nerdy to show some graphs and say that's what motivated me into my field. But it's true. I saw this graph in college and thought, oh my gosh, we're doing something to the planet. We need to learn more about that, and we need to do something positive for the planet because of that. What's even more interesting is that we've actually been studying the greenhouse effect since the mid to late 1700s. Joseph Fourier was the first to understand the effect of the atmosphere on keeping the planet warmer than it would be without it. And then Tyndall and Arrhenius studied the effect of carbon dioxide. So this isn't a new thing. This isn't some fad that we're just getting into now. So I decided I wanted to go to grad school and study this a little bit more. I pulled out my grad school application, which I wrote about 10 years ago, and found this sentence toward the bottom. I'm interested in developing biogeochemical models and ultimately applying this knowledge to work towards solutions for rising carbon levels. To put this in much simpler terms, science can and will solve our problems. This is an approach that a lot of people have taken in my field. And I think it's really important to highlight this issue that we've actually known most of what we need to know to bring about the necessary political and social change since 1979. I don't know if anyone's caught this piece in the New York Times Magazine. Really long read, fantastic piece. I highly recommend it. But this is really interesting to me as a scientist who studies these things, that we've understood most of what's going on. We still have a lot of details to work out. There's still differences between, is sea level going to rise 7.5 feet or 8 feet? Is temperature going to go up by 2 degrees or 2.5 degrees? There are details that we need to know, but we know that we're affecting the planet. So the second community that I'm now going to talk about is my scientific community, and how do we actually get people to care about this? One of the first approaches that often comes to mind is shove it down their throats. For those of you who can't read this, certainly you can probably see it on the left. It says, scientists, research concludes, we are destroying Earth. In his hand, he has a pamphlet of facts. And then he's talking to two politicians who say, could you kindly rephrase that in equivocal, inaccurate, vague, self-serving, and roundabout terms that we can all understand? I think this slide, it's kind of funny. It's kind of not. This is my life. We spend a lot of time thinking about this sort of thing, and why don't people get it? We have these facts. Why can't we just give them facts and they'll understand it? So I sat down in my office and thought, there has to be a better way. We're clearly not doing this the best way we possibly can. You can see that's me spending some time in deep thought there with my office equipment, research equipment in the background. And you can see, this is the first paper I published, Best Practices for Autonomous Measurement of Seawater pH with the Honeywell Durafit. Kind of dry, not really necessarily gonna lend itself all that well to communicating science. I get bored when I read that paper. I can't imagine what people who aren't specializing in this field might think. But we have these two cool instruments down here, the CFET and the CFOX, which measure pH and dissolved oxygen of seawater. We've deployed over 200 of these over the world, coral reefs, seagrass beds, Antarctic sea ice, really everything you can imagine, and learned some really fascinating things. But it's still staying largely in scientific publications. So I took out my sketch pad, and I thought there can be some other ideas that we can put together, other ways that we can get this equipment out into the ocean, into the coastal environment. And I'm not a very good artist. I apologize to those of you who are, if I'm offending you with these drawings. But started sketching up ways that I could just put that sensor on the back of a stand-up paddleboard or drag it through here. For anyone who's good with CAD, I'd really love to see what the actual thing would look like if you built this device that I've drawn here. That would not be a surfable thing. I don't know what it is, though. So I thought there's this kind of big idea of getting the sensors into the coastal environment with the goal being connect it with more people, talk to more people in the coastal zone about what's going on. But I just got way too lost in my big idea and wanting to solve all of our environmental problems just by, I don't know, sketching and thinking about how to bring everyone involved that I possibly could. So I found a mentor. This is my good friend Tim Ray, who had some other really similar interests in combining athletics and outdoor sports and environmental science, had devoted a lot of his life to many of the same things. So I asked him, what do you recommend that I do, and are you interested in being involved? Tim's advice was really simple. Just start. Just do something. And so I took the sensor we already had, and I took ratchet straps, and I put it on the bottom of my paddleboard, and I don't know why I thought this was going to work. It was a disaster. The very first stroke that I ever took on this paddleboard, amazingly, my lab mate and good friend Yui Takashita, who is here in the audience today, was able to capture this picture. The very first stroke I took on that paddleboard, I didn't even move. The paddleboard just stayed in position. There was so much drag from that paddleboard, from the scientific instrument on the bottom. I just didn't stand a chance. So I iterated, I failed a little bit more, iterated, failed a little bit more. We brought in a mechanical engineer who actually was able to bring that sensor design into a form factor where it could fit on the bottom of stand-up paddleboards. And on about take 4, maybe, we got this thing into a form factor that could be just mounted on the bottom of a stand-up paddleboard. Picture that Brittany Hook, who's here in the audience, took with a group of kids from Mission Bay High School on Earth Day of 2015, I believe. So after a few different iterations, we were able to get this into a way that we could get people out on the water, we could have them making chemical measurements with us, understanding things like ocean acidification and changes to the natural environment due to human activity in a really direct way that they weren't able to before. It was an amazing thing to be able to bring these two fields together, but it still wasn't quite community science. It was still talking about this nice, sophisticated instrument, but we only had one of them. It cost $15,000. It was really hard to operate. It was not going to be something we were going to be able to distribute to broader audiences. And so I was really lucky when I was asked about a year and a half ago to join the SmartFin team as a researcher at Scripps Institution of Oceanography. And this is the final community I want to talk about today, the global surfing community. First, what is SmartFin? SmartFin is a printed circuit board. You're looking at rows of printed circuit boards here with sophisticated scientific instruments on them, and they're put into actual fins, physical surfboard fins. This is a Futures side fin. How many surfers do we have in the audience today? About half of you, awesome. So there are a couple different groups of fin boxes. One is called Futures. This fits in about half of the surfboards that are out there. We more recently came up with a longboard version. I'm going to tell you the people who actually make those fins are in the audience. I'll tell you about them in a moment. But what we're capable of doing is measuring temperature, GPS position, motion, which can tell us what the surfer is doing to a certain extent, what the waves are doing. We have wireless data transfer and wireless charging, so a custom iPhone or Android app. And as I said, it fits in standard fin boxes, so we're able to have you take out your carbon fiber or plastic fin, put one of these in, just go surf, and you're collecting data, and you're part already, just by doing that, of the scientific community. Thanks, I really needed a pause there. My full-time job is kind of making new printed circuit boards, making them as robust as possible, and then largely on this last bullet point here, making many more sensors. So putting pH technology on here, dissolved oxygen, chlorophyll to study algae blooms, eventually, many years in the future when the sensors are small enough, bacteria sensors so that we can figure out exactly what's happening, exactly where you're surfing at all times. The way it works right now, as I said, is you have your fin, you sync it up with your mobile app, it pulls across all of your ride history, and then it gets all sent to the cloud where we have access to everything. This is freely available to anyone who's interested in looking at it, whether you're a surfer, a scientist, neither. You can access all of the data that people have been gathering and start to understand a little bit more about the coastal environment. I put this figure together to show the spread just over the last year. We first gave out fins in early June of 2017 to a broader community, and over the last 14 months or so, this is where we've spread. So you can see, it'll start over here, the spread from Southern California to communities in the northeast of the US, Hawaii, some collaborators in England, Australia, and then rides popping up in Central America, Latin America, Fiji, middle of the Pacific. This is awesome, but there's so much more happening behind those dots. The really exciting thing about this project is that communities are now forming themselves. They're coming together on their own and talking about how they can get involved. They're reaching out to us and saying, we want to start a chapter here. We want to get people more engaged in science. We want to answer some specific scientific questions, or we want to get our surfers more involved in what's going on out there. Another really interesting thing that's happened more recently is at Scripps Pier, we've been measuring the temperature for over 102 years now. And just in the last 2 weeks, we broke the record from the 102 years of measuring 4 times. So we now have the 4 highest records just from August of this 102-year record. So I wanted to go out and see what's happening out there at finer spatial scale than we'd be able to do from a single point measurement. Took my paddleboard, this time with a SmartFin, did not fall a single time, and zigzagged back and forth, and this color scale represents a change in temperature. So this little blue patch here is showing you a colder blob of water, colder blob of water here, and then warmer here. And this is just to show you one of the scientific collection examples that we can do with SmartFin. So we can start to really map ecosystems in a way that we haven't been able to before in these fine spatial scale ecosystems, so that we can start to ask and answer questions like how variable are coastal parameters and how does that affect the organisms that live there? Things like coral reefs. We know coral reefs are bleaching at massive scales because of temperature increases, but they're not bleaching evenly across entire reefs. So can we see fine spatial scale variability that might affect one part of a reef but not another with this new technology? We think so. How do surf breaks change with sea level rise and coastal development, new seawalls? Where are people actually surfing on a daily basis? And there's so many things that we haven't even been able to think up to ask because we just haven't had the technology to do so until now. I'm just a small part of an awesome team. Fortunately, I have a few of these people in the audience today. So I'm at Scripps, as I said. Dr. Tyler Ciernak is here today as well. He is the lead researcher on the project. He's doing many of the analyses that I mentioned on the previous slide. We have this fantastic engineering team here, a couple different people who are working on different parts of the technology. And then Lost Bird Project is a nonprofit based out of New York. Their mission is connecting more deeply with the Earth through art. And they first put together a couple documentaries around lost birds, extinct birds, where they got their name, and then came up with this SmartFin idea and connecting science and communities and surfers. So this is a big part of their team. Most of the pictures on this slideshow that I haven't labeled were taken by Kat Hammond, who's in the audience here. All of the fins that I'm showing today have been built by JR, who's sitting back in the audience there as well. I'm not sure if they're going to stick around too long after the talk, but try to catch them on their way out if you have other questions. We're also collaborating closely with the Surfrider Foundation for one of our main distribution partners. This slide is what gets me really, really excited about the broader community that we're a part of. I took a couple logos from the websites that I could find in a really quick search. I'm sure I left people out. I already realized just in the quick pitches this morning, I don't have I Love a Clean San Diego on here or the Paddle for Pints, but the logos I'm showing here are the Southern California groups that are involved in cleaner waters or ocean aid in some way through the means of surfing. So we have groups like Changing Tides Foundation, which is trying to improve the way that people travel more consciously. Think about their carbon footprint while they're out there and actually try to help local environments while they're out there if they're going on a surf trip. We have groups like Urban Surf for Kids, Outdoor Outreach, who are giving kids opportunities to surf and do other outdoor sports that they might not otherwise have access to. Surfrider, I already mentioned, Coast Keeper, Sustainable Surf, Waves for Water, groups that are working on improving water quality and activating other parts of the community, getting people more and more engaged. This, to me, just speaks volumes about the power of surf. Surf is something that's really meaningful to a lot of people here in Southern California and around the world, and it helps to bring people together. It's just this exciting, fun thing. We don't have to show graphs of the Keeling Curve to get people engaged. We can go out in the water and talk about these other opportunities to bring people onto the team and into the community. I really hope that you join us or one of the groups that you saw on the previous slide. And I mean that in a really broad sense. It would be great if you actually joined the SmartFin family. But there's so many great communities here in Southern California. Here are a couple of the lessons that I've learned. We still need lots of science. I don't want to give you the impression that because we've been studying global warming since the 1700s and because I claimed that we know everything we've needed to know since 1979, that we can just drop it. There's so many important questions out there that we haven't even begun to approach that are going to have really important implications for human health and environmental health moving forward. But not just science. There's a lot more that we can do beyond just studying things and being in our labs and in our offices. This is the way that I get out of the lab and out of the office and connect it with the broader community. This is the point that really drove it home for me. Talk to people about your passions, not just their political implications. I think the fact that I can now go back to Pennsylvania and talk to people about what I do because it circles around the idea or centers around the idea of surfing and something that's really fun and something I just love doing allows me to have conversations that I never would have had otherwise if I just went home and said I was working on best practices for autonomous quality control of the Honeywell Durafit for perhaps obvious reasons. And then last, surf or sup or hike or bike. I think there's a lot of value in getting outside and connecting with the local environment. There's so much great stuff here, and I think it gives us all a better sense for the value of this ecosystem that we're a part of and this broader community that we're a part of. And to summarize all of it, and using Tim's words, just start, because you're gonna fail, but do something and it'll get better.